live. Welcome back, all of you. We're going to be doing an awful lot of trig the first few months, and you did some trig last year and in theory in Math 10, but I think your group in grade 10, for some reason, the Math 10 teachers never got to it. You need to be familiar with right angle trig, with sine and cosine and tangent. So here it is. Oh, and Pythagoras. So we're going to be dealing a lot with triangles. This is a review of trigonometry. I hope you all know this. If you don't, that's okay. It says find the length of the missing side. How would you find x here? Yep.
We can find it by using the angle of 90 degrees.
And then there's a word in English. It starts with the letter P. It's named after a Greek mathematician. P-Y-T-H. Anybody? Okay, we can use Pythagoras. If we have two sides, we can find the third with Pythagoras. Pythagoras is typically written as a squared plus b squared equals c squared. Some teachers use s1 squared plus s2 squared equals h squared. Side 1 plus side 2 equals hypotenuse squared. Whatever. The key is the x does not always go there. The hypotenuse has to go there, which in this case is the 73. So if I was solving this, I would go 55 squared plus x squared equals 73 squared. I am fine in grade 12 if you are good enough at Pythagoras that you write nothing down, that you go straight to your calculator and you just write an answer. And in fact, you're going to see I do that fairly often. Not on a test. On a test, I will show all my steps because I don't want to make a dumb mistake. Where's my seating plan at, by the way? Right there? Thank you. Everybody comes out? Okay, I can learn names now. Much better. So in order to do this, we use Pythagoras, if you want to write that there. And typically from this line, I would go to my calculator, but I would do some steps in my head. Matt, how am I going to get the x squared by itself? How do I move the 55 squared over? So I would go to my calculator, and I would go, hang on, someone at the door. Pause the video for a second. Matt, because I'm naturally lazy, I like to take, I think I used the phrase last year, organized but lazy. I said that fairly often. So although your math 8 or 9 teacher might have made you rewrite all this, I would just go 73 squared minus 55 squared equals, and then I would go square root, answer button. You want to, if you are not familiar with your calculator, figure out where the answer button is and figure out where the square root and all that stuff is. And I strongly encourage all of you to get in the habit of following along on your calculator because it's an easy way to be actively involved. And I made this one work out evenly. Most of the time, your answers will not work out evenly, but I played around with some numbers and you get x equals 48. And in physics, we always have units. So those of you, my new students, I'm fussy. Your final answer better have units. If it does not, I'll take a half mark off every time. So one of the things you always want to do before you hand in a test is check to make sure your answers have units next to them. This one probably won't work out evenly. Do example 2 on your own. Find the missing side. 17.74, blah, 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 blah. I know you're having a little deja vu. Mr. Dueck, how many sig figs do you want us to go to? I'm going to say in grade 12, we're going to go to 2 or 3 sig figs for every final answer. And if you don't know what sig figs are, I'll explain that another time. But for now, I'm going to write this as 17.7. 0.7, Mr. Dueck. Centimeters. And you know what? Let's even go like this. Put that there. And I could even put my calculator there so people can see what the heck we did. We can find a missing side in a right angle triangle if we know 2 of the sides. And you learn that, I think, in our curriculum. Pythagoras is still math 8, I think, yeah? I think it's because they want to introduce in grade 8 the idea of a square root to you, and a good way to introduce square root in context is with Pythagoras. Then in grade 9 or 10 or 11, depending on your teacher, or earlier, depending on which country you're from, we start to get into some serious trigonometry. We realize that actually in a right angle triangle, all you need are 2 things. any angle and a side, or two sides, and you can solve the entire triangle. But first we have to label sides. So it says, label the following triangle with opposite, adjacent, and hypotenuse. I have the habit of, once I see which angle we're talking about, I often go color, 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 just to help my brain focus on it. It's a dumb way, lazy way for me to make sure I know which angle I'm talking about. So all triangles, Captain Obvious, have three sides. This one here, is it the opposite, the adjacent, or the hypotenuse? What's the hypotenuse? How do we define that? Well, there's several ways. You can say, well, it's always the longest side in a right angle triangle, which is true. You can say it's the one across from the 90-degree angle. I had one teacher that used to pretend that was an arrow and that it pointed towards the hypotenuse. Whichever you want to do, but for now, let's put a little lowercase h there. This one on the top, opposite or adjacent? How do you know? Well, the word opposite in English means facing. Right now, Adam and I are opposite each other. We're really opposite. No, we're opposite each other. We're facing each other. And so the side that's facing angle theta is that one there. Now, if we change angles, the opposite side changes. The adjacent side, well, the word adjacent means beside. Right now, Brendan and Adam are adjacent to each other, and so that's that one there. You have to get very comfortable with being able to label sides in your sleep, and you will. We also have three primary trig ratios. What are they called? They're buttons on your calculator. Sine, not sin. It's a sin to call sine sin. So sine, abbreviated SIN. Cosine, abbreviated COS. And what most of you did this summer, tangent, abbreviated tan. By the way, I wrote the word primary trig ratios. There's also what are called the reciprocal trig ratios, which I think you do in Math 12 in our curriculum. So you'll learn about secant and cosecant and cotangent. You don't have buttons for those on your calculator because secant is just 1 over sine. So if you want to find the secant of something, you find the sine of it, and then you go 1 divided by answer button. Cosecant is 1 over, sorry, secant is 1 over cosine. Cosecant is 1 over sine, and cotangent is 1 over... Did you do it in grade 11? Did you do the reciprocal trig functions? I can't look at you. You've done Math 12 already. People not... Okay, whatever. You also have to be able to use your calculator. Now, if you have a good calculator, you can evaluate the sine of 42 by going sine 42. If you have a crappy calculator, you have to type 42 sine equals backwards, talking strangely, writing backwards strangely. I hate calculators that do that. I would much rather be able to type things in the same order that I write things. But for now, on your calculator, however your calculator works, can you find the sine of 42? And you should get 0.66913. And if you don't, you're probably in radians. Probably. If you have a good scientific calculator, by the way, anytime you reset it, it will probably go to radians by default. Certainly the graphing calculators, if you reset them, they'll go to radians by default. So you want to make sure for physics that you're in degrees. About 10 years ago, it was our final exam, and I had a student sitting right where Chelsea is back there. I was doing my Physics 12 final. We were about an hour in. The room was quiet, and I heard a noise. It was a disturbing noise. If you were feeding a cow into a wood chipper, kind of a, and it was Jordan sitting back there. He had been doing his whole test with his calculator in radians, and he just figured it out, which is why he couldn't find any of my answers on the multiple choice section. And often when you're in radians, you get negative answers. So he was finding scalar values that he knew were supposed to be positive and getting nonsense negative stuff. He figured it out about an hour in, and without even looking up, I just said, hey, make sure you're in degrees, because everybody knew that was the mistake. So my warning to you, Nick, make sure you're in degrees in this class. You will, those either doing pre-calc or calculus, you will be doing your trig primarily in radians. And so you'll have to get into the habit of switching to radians for Math 12 or pre-calc 12 or calculus and back to degrees. I used to have some kids, they would actually have two calculators. They would have a scientific one that they used for physics and degrees, and then a graphing one that they used for calculus and radians, whatever works better for you. 0.669, I'll go to 3 sig figs. Oh, 4 decimal places it says, so 0.6691. Yes? Good, find the next 4. Next 3, Mr. Dueck, shut up. Tan of 45, I know. And you should find D is a little strange. What did you get when you tried finding the tangent of 90? Error. Really? You know what? Let's sneak up on it. What's the tangent of 89 degrees on your calculator? 50. How about what's the tangent of 89.999? 3 nines after the decimal on your calculator. This is an old trick. We're going to sneak up on it. What'd you get? I'm looking at you, Brennan.
57,000.
A bigger number? What's the tangent of 89 point... How about 6 nines after the decimal? Yeah. What happens, the tangent graph, as it approaches 90 degrees, it shoots right up to infinity. If you wanted me to say, what's the tangent of 90, I could say, well, infinity, I guess. Those of you that are in calculus, we would say the limit of the tangent function as theta approaches 90 approaches infinity, if you want the fancy schmancy speak, but it kind of shoots off to infinity. Okay, so if you want to, you can do the infinity symbol, which is the number 8 on its side. We can also use our calculators to go backwards. If in my calculator you give me an angle, I can tell you its sine or its cosine or its tangent. Also, if you give me a decimal value that is a sine or a cosine or a tangent, I can tell you what angle it came from. So if I tell you that we took the tangent of a mystery angle and our calculator said 3.732, how can I find angle theta? Who remembers how to do that? On your calculator, it's either the shift button in the top left. In math speak, we would say the inverse tan or the arctan. It may be a second function button. It's almost always the top left button of your calculator. Some of your cheaper calculators, you might have to go 3.72 shift tan. On mine, I go inverse tan of 3.732. And I get that the angle we must have started with is 74.999. What angle did I start with? Yeah, 75 degrees. So I have 3 questions here. It says solve the following to the nearest degree. If sine of angle A is 0.5, can you please go backwards and figure out what angle theta is? I actually have this one memorized. Try it. If cosine of theta is 0.5, can you go backwards? I have this one memorized as well, but I don't have tangent memorized. And hopefully you got 30, 60, and 26, 25.99, 26 degrees, right? So we're familiar a little bit with our calculators. Then you can turn the page, I think. Or next page over. No, we're turning the page, aren't we? Okay. Then the last thing that we did is we defined those 3 trig functions, the primary trig ratios, sine and cosine and tangent. We defined them. We defined sine as opposite divided by or over hypotenuse. We defined cosine as adjacent over hypotenuse. I'm going to pause. I see kids shaking hands. Was anybody not able to get those? I should have paused and asked. So the calculators are working?
Not really.
Not really? Okay, we're going to pause the video for a second. And so now we put everything together. If you give me a right-angled triangle and 2 pieces of information about that triangle besides the 90, so I need one of the other angles and a side or both sides, I can find everything else about that triangle. So here, example 6a, I'm going to zoom in so you can see a little better in the back. It says, find the length of the missing side. Find x. They gave me an angle. I typically go color, 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 just to remind myself that that's the angle that we're looking at. I am lazy but organized. You may have had a teacher who always taught you to label all 3 sides. I think that's bad teaching. I'm only going to label the 2 sides that got stuff on them. This x, opposite, adjacent, or hypotenuse? I don't think it's hypotenuse. Opposite. Put an O there. I missed out. When you went, oh, I should have said, yes, you're right. I said, it's not the hypotenuse. You went, oh, I should have cut you off right there. Yes, you're right. Oh, missed out on a bad joke. The 15, adjacent or hypotenuse? Yep, put an H there. The reason I don't like labeling the third side, so some teachers say, well, put that on there. The problem is now I have 3 letters to pick from, Cole. I've made it tougher. It seems to me if I do that, I only have 2 letters staring at me. Which trig function has the O and the H in it? Well, we have this nonsense acronym that we come up with. It's called SOHCAHTOA in English, and I think in most of the other languages, I think sine still begins with an S, and cosine still begins with a C, and tangent still begins with a T, and I think opposite begins with an O, and adjacent begins with an A, and hypotenuse begins with an H, I think. So I think the acronym works in most other languages. If it does not, use your own system. But for now, coming back to Cole, which trig function has the O and the H in it? Thank you for saying sine and not sin. And so I write down sine. Let's change colors, Mr. Dueck. And then what always goes next to the trig function? The angle. And that's going to be kind of part of your mental checklist as you're writing stuff. What always goes next to the trig function, Cole? Which in this case is 57 degrees, equals opposite over hypotenuse, but I'm not going to write O or H. I'm going to plug and chug. It's going to be x over 15. Yes? Cole, how would I get the x by itself? More specific. Okay, so I did with my students last year a lot of formula manipulation. The fact that Cole was able to glance at that and say, dude, I can just multiply by 15. In your homework, if you go straight to your calculator now and just write an answer, I'm fine with that. In our notes, just so that when you're studying, you know, we know what the heck we did, I'm going to write what I think is a wasted line. I'm going to write, okay, x equals 15 sine 57, but also just to make a point, some crappy calculators, if you go sine 57 times 15, it might do this 57 times 15 first and then take the sine. So when you're multiplying a trig function, always tuck the number in front like a coefficient, because that I know that order will work on every calculator I've ever tried. So what's x? You get 12.5800585. Oh, wait a minute. What did it say in the instructions? How many decimal places? 1. So 12 point. Thank you for rounding off properly. Units, centimeters. Again, the same kind of an idea here. I'm going to label the 2 sides that they gave me. Again, because I like to do mindless color, color, color. It's also how my brain starts to think. Just by doing that, I avoid this, because the big one, kids mistake the hypotenuse and the other long side all the time. I find by doing that color, it forces me, as I'm doing that, to notice, hey, that's the, Adam, redeem yourself. This is 11.1, opposite, adjacent, or hypotenuse. Oh, what about this one? The x. Ah. Which trig function has the O and the A in it? What always goes next to the trig function? No, it's not what I said. I used a word starting with letter A. It's important because later on this year in pre-calc, you won't be doing degrees. So I picked a better word starting with letter A, A-N, A-N-G. Okay, what always goes next to the trig function? The angle, which in this case is 28 degrees. And it's going to be SOHCAHTOA, TOA, opposite over adjacent. Basically, when you're solving for missing sides, you're going to find, Matt, that either the x is on the top, and that's so easy that even Cole could handle it in his sleep. Oh, that came out wrong. Or the x is on the bottom. Blech. I don't like the x on the bottom. Wait a minute. Dividing by x on this side is the same as doing what with the x on this side? And so I got to be honest, this is my line of work. I'll write this down, and then I often go, no, I do that because I can think better that way. And then how would I get the x by itself? Divide the tan over. I'm going to write that step in my notes right now, but in your homework, if you reach the point where you can go straight to solving it from this line. In fact, many kids don't even need to move the x over and write that step. They just write this and I'm good to go. Some of you may even reach the point where you can just look at this, realize it's tan, and do the rest on your calculator. And in your homework, I'm fine with that. For now, though, so that we know what the heck we did when you're looking back at your notes, and also for the students that were away, what do you get? Now, one of the nice things with Trig is there is some built-in error checks. I will try and give you diagrams roughly to scale. Looking at this picture, x looks longer than 11.1 just when I eyeball it. I better get an answer bigger than 11.1. If I don't, I've probably done it wrong. 20.9. Yes? Units, centimeters. So you can use SOHCAHTOA right-angle trig to find missing sides. You can also use it to find missing angles. So example A, it says, find the measure of the indicated angle to the nearest degree. It looks like they want me to find angle X. Oh, you know what I'm going to do first? Color, color, color. You don't have to, but I just find that gets rid of a lot of my dumb mistakes. Nick, the 15, opposite, adjacent, or hypotenuse. The 7, which trig function is Yep. Nick, what always goes next to the trig function? That's why I didn't say degrees, because there isn't degrees here. But the angle, which I guess in this case is that. That equals adjacent over hypotenuse, 7 over 15. Nick, I think it was you who earlier said, how do we find an angle? How do we go backwards on our calculator? Yeah, this is the inverse or the arc or the shift or the second function. I'm going to have to put it in brackets. So I'm going to have to go inverse cos bracket 7 divided by 15. Now, if you have a crappy calculator, you'll have to go 7 divided by 15 equals, and then you'll have to go shift cos of that particular number. But regardless, you'll get the 62 degrees. By the way, I'm hoping I haven't taught any of you anything new today. Like, I hope this has been just brushing the cobwebs off because the summer. One more. Find angle Y. And again, I think I said to you there's built-in error checks. My diagrams will be roughly to scale. Looking at angle Y, it looks fairly small. If I get 88 degrees as my answer, I've messed up. So, you know, there's some built-in error checks. Color, 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 color. Maggie, that 8.1, opposite, adjacent, or hypotenuse. How about the, yep. And are you seeing why I prefer to leave the other side blank? It just cuts down on my thinking so much. Otherwise, I'd put the A, and then my mind, I'd have to erase the A. Well, why not just not put it in the first place? So, which trig function, Maggie? Sorry? You're correct. What always goes next to the trig function? The angle, which in this case is what? Because I asked you to. Oh, don't want to play my little game, do you? Okay. Why? Because I asked you to. Why? Because I asked you to. Why? Dumb jokes. 8.1 over 14.5. 34 degrees, yes? Mr. Dueck. What, Ryan? If I can just label the triangle, clue in what trig function it is, and go straight to my calculator without even writing that step there, you okay with that? Sure, in your homework, knock yourself out. Become an expert. Again, on a test or a quiz, will I show this step just to make sure I don't make a dumb mistake? Absolutely. But in my homework, will I try and do it as expertly as possible? Yeah. So go ahead. I will assume you didn't cheat. There are two terms that we use in physics. One is an angle of elevation, and one is an angle of depression. An angle of elevation looks like this. If you're standing on the ground, that there is an angle of elevation. For an angle of elevation, you raise or elevate your eyes. You start here and your eyes go up. You've just moved your eyes through the angle of elevation. And then there's something called an angle of depression. When you're depressed, you lower your eyes because you're depressed. That's from the top of a cliff. So draw a little cliff. Draw a little dotted line straight out like that. The angle of depression is this one here. A lot of times when students see the phrase angle of depression and it's a cliff question, they want to put it next to the cliff. That's not the angle of depression. That's the angle of depression. You lower your eyes because you're depressed. You're going to see that in some of the wordy problems. What's your homework? You can do all of number one, show as much or as little work as you need. If you can do each question for number one, showing no work whatsoever, going straight to your calculator, I'm good with that. Answers are on the back page. All of number two, I know number two has a subpart 2 and 3, so I'll circle both of them. Again, if you can do those showing no work whatsoever, great. All of number 4, all of number 5, all of number 6. 7 is good. 8 is good. And answers are attached.